Hello, today we're going to be looking at the product rule. So, this is a way that we can find the derivative of two functions that are being multiplied together. So the first thing I want you to do, or actually first of all, so remember from lesson 2.2, we found that if we had a function p of x that was equal to two functions added together, f of x and g of x, then the derivative of p of x was simply the derivative of f of x plus, the derivative of g of x. Okay, so using that, what I want you to do is I want you to complete this, pause your video, complete this little investigation. It should only take a couple minutes, and then come back. All right, so we are going to look at the product rule. So, the product rule, I misplaced my answer sheet. All right, there we go. All right. So first of all, what the product rule is. So, if we have a function, which we will call h of x, and this function is made up of a function f of x being multiplied by a function g of x. Unfortunately, as you hopefully learned in your investigation, you cannot just take the derivative of f of x and multiply it by the derivative of g of x. That does not work. So what you're going to do is you're going to follow this handy little formula. And what we get is that this is going to be equal to the derivative of f of x times the derivative, or just the regular function g of x, plus the regular function, oh, for crying out loud, there we go. Okay, the regular function f of x times the derivative of g of x. And that is what we call the product rule. Okay? So, let's go up. Oh, wait, yeah. So here we go. So let's take a look at this first example here. F of x is equal to 2x squared minus 9 times x cubed plus 5x. So what we're going to have, and I'm going to do some steps that long term you may start dropping, but for now we're going to do them. So what's going to happen is you're going to say, all right, so first of all, we're going to take the derivative in terms of x of 2x squared minus 9. Okay? You're then going to multiply that by the function x cubed plus 5x. Okay, we're then going to add, and I'm totally going to go into B's space here because some of these are quite lengthy. That's okay. And we're going to multiply that by 2x squared minus 9 times the derivative with respect to x of x cubed plus 5x. Okay? So there we go. So let's actually do it. So let's go over here. And the derivative of this first one here is just going to be 4x. And the derivative of minus 9 is just 0, or well, yeah, it would be 0. Whatever. So we leave it. Then we've got times x cubed plus 5x plus 2x squared minus 9. And then the derivative of that would be 3x squared plus 5. There we go. So, we can simplify this. We won't always simplify these ones, but if you expand it out and collect like terms, we're going to be left with 10x to the 4 plus 3x squared minus 45. Okay, and that's that. So let's take a look at the next one. And the next one you'll notice actually gives us an x value, which I just drew right through. Let's try that again. It gives us an x value. There we go. Okay. So I briefly spoke about this in class, about a common mistake people make where they will sub in the value x equals 2 before taking the derivative, which of course means that your derivative just equals 0. And that's wrong, okay? So don't do that. You have to take the derivative and then we'll sub in the value. So let's just, let me just create a barrier here so that we don't get messed up. There we go. Okay. So what we're going to have, first of all, I'm going to start down here so I have a little bit more room. Okay, I'll try and write smaller. Maybe I'll zoom in so that I have more room. Okay. So this is going to be, so first of all, we're going to take the derivative of the first part here. So the first part being 2x squared plus 3x minus 1. Okay, and then we're going to multiply that by the second function, which is x cubed minus 4x squared plus 5x. Okay? And then we're going to say plus, and we take the first function, so the 2x squared plus 3x minus 1 times the derivative of x cubed minus 4x squared plus 5x. Okay, so there we go. So that's what we're going to do. And once we find this, we can sub in the 2. So let's go through. And we're going to say, well, the derivative of the first part would be 4x plus 3. And we've got times x cubed minus 4x squared plus 5x. And we're going to say plus 2x squared plus 3x minus 1 times 3x squared minus 8x. Whoops, I missed the plus 5. There we go. So there we have it. So there's our derivative. Now we're evaluating it at x equals 2, so we're going to go through and we're going to sub in 2. So we want to find f prime of 2. So we're going to have 8 plus 3 times 8 minus 16 plus 10. 8 plus 6 minus 1. 12 minus 16 plus 5. Okay. And you can just put that in your calculator. And you feel free to double check this. I did do it ahead of time and I got 35. Okay. And there you go. All right. All right, so I know what you're thinking. You're thinking, I'd really like this if it was a little bit harder. And fortunately, that's exactly what we're going to do. So first of all, our first question here is, what if it was just a function squared? We can use the product rule to figure this out. Okay? And hopefully we can find some more simple rules, which we will be able to by taking a look at these. But if we have f of x squared, what we're going to do is we're going to say, well, then that would be f prime of x times f of x plus f of x times f prime of x. And because multiplication doesn't matter, this is equal to this. So I can just say that it's 2 f of x times f prime of x. Okay, so that one's not actually that difficult. This next one is not that difficult either, but it's quite tedious. There's going to be quite a few steps here, quite a bit to write out. So, q prime of x. So what we're going to do is we're going to say, all right, let's treat h of x times g of x as a separate function to begin with. Okay? So we're going to say, all right, then we've got f prime of x times h of x times g of x, because I'm just treating those as one thing. And then I say, okay, well then I'm going to have plus f of x times the derivative of h of x, whoops, times g of x. Okay, so now I just have to figure out what the derivative of h of x times g of x is. So we'll leave this. We got, here I'm going to zoom in so I can write smaller again. We've got f prime of x times h of x times g of x plus f of x. And now we'll take the derivative of that product. So we'll have h prime of x times g of x plus h of x times g prime of x. Okay, so there we go. So now I can expand the f of x into those brackets, and what I'll get is f prime of x times h of x, g of x, plus f of x, h prime of x, g of x, plus f of x, h of x, g prime of x, which actually kind of makes sense. So you can see whoops, oh, I lost it. Where did it go? There it is. Okay. So you can see I've just got the derivative of each multiplied by the original function, the original function, the original function. And then we just add them all up. Okay? There you go. So, if we follow that pattern, we can then do a more complicated one where we've got g of x to the power of 3. And so what we'll find is we have p prime of x, oh, hold on a second, of a function that's been cubed. So what we're going to do is we're just going to treat it like we had over there where we had 3 different functions. So we had g prime of x times, and then there was g of x times g of x, which I'm just going to write as g squared of x. Okay. Then we had another one, which it was g of x times g prime of x times g of x, which of course, since order doesn't matter, I'm just going to write it again of g prime of x times g squared of x. And then we've got one more, same thing, order and multiplication doesn't matter, so we can write it as g prime of x, g squared of x. And if you look, we now just have 3 of these things that are all the same. So what we can conclude is that the derivative of p of x would be 3 times g squared of x times g prime of x. And that's it. Okay. So what this actually can lead us to then is what we call, the power of a function rule for integers. Okay, so what this is if f of x is equal to g of x to a power. Okay, it doesn't matter what the power is, so we'll call it n. then the derivative of f of x is going to be n times g of x to the power of n minus 1 times g prime of x. So it's almost like we're treating this whole thing just as the way we would take the derivative of a polynomial. We put the n out front, we reduce it by 1, but then we have to multiply it by the derivative of whatever that function is. Okay? So let's use that to do a couple more complex ones here. So our first one we have here, you can see, is we've got this whole polynomial here, all raised to the power of 7. So what we're going to do is we're going to treat this whole thing, just leave it how it is. We're going to take the 7 here, okay, and we're going to write it out front, and we're going to multiply it by 6x cubed minus 5x squared plus 3x plus 11. And then we're going to put it to the exponent of 6 because we have to reduce that 7 by 1. Okay? But now what we have to do is we have to multiply that whole thing by the derivative of this internal function, this polynomial on the inside. Okay? So we're going to take the 3 and we're going to multiply it by the 6. So we get 18x squared minus 10x plus 3. And that's it. And there you go. Now, I know we're used to simplifying things and reducing them at all times, but in this context, it's really not necessary, and it would actually be incredibly difficult to do, and it would take you forever. So you can actually just leave this as your final answer, and that's fine. It's a usable version of the function, so there's no reason to go any further. Okay. So B here, this one's going to be fun because there's a lot going on here. So what we're going to do, okay, so we've got our first function to the power of 3, and then a second times the second function to the power of 2. So we're going to have to use a lot of different rules here. Okay, so the first thing we're going to do is we're going to take the derivative of 2x minus 3 to the power of 3. Okay, and then we're going to multiply that by 6x squared minus 1 to the power of 2. We're going to then add that to 2x plus 3 to the power of 3 and multiply it by the derivative, well, I'm running out of room here, of 6x squared minus 1 to the power of 2. There we go. Okay. So, let's go through step by step then. So to take the derivative of 2x minus 3 all to the power of 3, we're going to say, all right, well then that's 3 times 2x minus 3 to the power of 2. But then we have to multiply that by the derivative of 2x minus 3. So that's going to be 2. Okay, then we have to multiply it by 6x squared minus 1 to the power of 2. And then we go over and we say, all right, plus, and we'll just leave our function here. And then we take the derivative of all of this. So we're going to have times 2 to the, or times 6x squared minus 1 to the power of 1. I don't have to write that. And then I have to multiply it by the derivative of what's inside there. So I'm going to get 12x. And that is it. Okay? And again, I mean, we could expand that, we could simplify it, but there is no reason to. All right. All right. So there are 3 more questions here, and I want you to do your best. Some of them are quite tricky. Okay, I want you to do your best to attempt those so that we can do them together at the beginning of next class. So until next time, go Sabres.